Sample problem 8.3. Using data from figures 7.8 and 7.10 and appendix 2, calculate the lattice energy of cesium chloride, CsCl. Okay, so let's remind ourselves, what is lattice energy? It's the amount of energy holding all the ions together in an ionic compound. Okay, the lattice energy is the attractive energy that's responsible for the stability of ionic compounds. Okay, it is not something that we can measure because it is too complex to measure. So we figure it out using Hess's law, and this application of Hess's law is called the Born-Haber cycle. Okay, so let's take a look at it for cesium chloride. Now, as you do these problems, you might want to look at the picture that's in your textbook, figure 8.6. That gives you a whole picture of this whole Born-Haber cycle. But what I've done is I've selected all the reactions that we need and the delta H values from figures 7, 8, 7, 10, and appendix 2 to figure this out. But there's a couple of little details here that are nitty-gritty. But first, let's prove that if we add these delta H's together, it'll give us the right answer. Okay, so first what I'm going to do is I'm going to start canceling everything that appears on both sides. So if you see anything that appears on both sides, we can cancel it. So cesium as a solid, that's an S for solid, cancels. Cesium as a gas is on both sides, so it cancels. 1/2 Cl2 gas. It's got to be the same state of matter, right? And then Cl gas. Electrons. And so it looks like we got everything canceled out. So overall, it's Cs, Cl solid, goes to Cs plus and Cl minus gas. And that's what we were looking for. Delta H would be the lattice energy. That's the amount of energy it takes to rip these ions apart in the solid phase and put them into the gas phase, the attractive energy. Okay? So that means if we go ahead and add all these up together, we're going to get the right answer. And if you do, if you take 442.8, 76.5, 121.7, 376, and negative 349, you should get a value that's the lattice energy for CsCl. And if you look in table 8.1, CsCl is not given there, so you can't look up the value there. But it should come out to about 668. So let's run it through. 442.8. 442.8 plus 76.5 plus 121.7. So 76.5 plus 121.7 plus 376 minus 349. 668. So our answer should be 668. It's positive. Lattice energies are positive because of the way they're defined. They're defined as the amount of energy it takes to rip the ions apart and put them into the gas phase. It takes energy to rip ions apart, that's endothermic, and it takes energy to form ions, so that's also endothermic. So overall it should be endothermic. Now let me go over just real briefly where these numbers come from. In the first step, CsCl solid goes to Cs solid plus 1/2 Cl2 gas. That's just the reverse of the heat of formation of CsCl2. Remember, the heat of formation of a substance is you take the elements and then you form the compound, 1 mole of the compound. So this is minus the heat of formation of CsCl2. So you look up the heat of formation in Appendix 2. The negative of that is positive 442.8. CS solid goes to CS gas. That's also a heat of formation in Appendix 2. So that's not the minus heat of formation, it's just heat of formation of that. That equation, CS gas from CS solid is in there. So you can just look that up in Appendix 2. So this one's Appendix 2. This one's Appendix 2. But the first one, you have to take the negative of it. The third one, same idea. This is just Appendix 2. 1/2 Cl2 gas goes to Cl gas. So the formation of Cl gas is in Appendix 2. So you're just going to use that value. The fourth one is what's called ionization energy. So when you take the element and you take its outermost electron off, that's called the amount of energy associated with that's ionization energy. So this one is in figure 7.8, back in chapter 7. And then the last one, that's gaining an electron. When an atom gains an electron to become an ion, that's called electron affinity. And that's in figure 7.10. Okay? So two figures, tables. They're really tables, but they're shown as figures. 7.8 and 7.10 will give you the last two values.